Good day, grade 12 learners. Welcome to today's technical science lesson. My name is Mashidu Mamburu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saipono Discovery Center. Today, tech science learners will be doing revision, focusing on waves, sound and light, electricity and magnetism. So those are the topics that we're going to look at. And you are saying for your paper one, you can be able to collect as many marks as you can from these topics. And I hope after this lesson, you will have gained a lot and you will have confidence towards writing your exams. Now, as usual, we always like to tell you, to remind you that in paper one, you have electricity and magnetism with 33 marks, and you have wave, sound and light with 24 marks. So if you are to add, you have 57 marks that will come from these topics that we are talking about today. The other 93 marks comes from mechanics. So we have been dealing with mechanics. We said it will be better today. We deal with electricity and magnetism, wave, sound and light. And these topics, you can collect as many marks as you can. So if you can see, it's 22% of the paper, electricity and magnetism, wave, sound and light is 16% of the paper. As you know that your paper one is out of 150 marks, you'll be writing for 3 hours. So I'm hoping that you will be able to get out of these 57 marks, you'll collect as many marks as you can from today as you prepare for your final exams. Now, you will always like to remind you that you will have 20 marks that comes from multiple choice questions. You can as well have 8 matching items or 1-word items, but if we look at the previous papers that we had, we never had these 8 matching items or 8 1-word items. We had the 20 marks multiple choice questions. So this is what you're expecting in your paper, the 20 marks from multiple choice questions, and then we can have matching items or 1-word. But if it's not there, you will have 130 here. If the matching words are there or 1-word is there, you will have 122 marks for the structured questions. So this is the structure of your paper. As I indicated, you will be writing for 150 marks, and then you have 3 hours that is allocated towards yourselves and paper one. Now, we are always emphasizing the use of the exam guideline. This is our everyday song, that as we meet, we'll always remind you that your definitions must be from exam guideline and shy away from using other sources for your definitions. Instead, use your exam guideline. We are saying all or nothing, so we are saying it's either you know the definition or you don't know it. And we are saying what we look at when we're dealing with definitions is your keywords. And we're emphasizing that ensure when you read the definition, it must make scientific sense. Look at that. It's not sense, it must not make sense, but it must make scientific sense. Every long question in section B will require you to remember a definition or two. So these are easy marks. So we're saying these are recall questions where you just say define, ensure that you are able to collect as many marks as you can from the definitions. Now, we also put more emphasis on the use of the data sheet, because your data sheet can help you in terms of your definitions, in terms of choosing of the correct formula. And then we are saying now you can be able to know whether the question is a routine calculation or not. If it's a routine calculation question, you will have 3 marks, for example. That's where we're expecting you to write the formula, the substitution, and the final answer. And we're saying that answer must be incorrect unit. So the SI unit must be correct at all times for you to get that last mark. And if you are dealing with vectors, you must have direction. So we are saying FSAUD, don't forget that. We are saying as long as you are dealing with calculations, you will go to the data sheet where you will get your formula, and then you will be able to substitute in your formula, and you will write your answer with correct SI unit, and we must have a direction if we are dealing with vectors. Now, we are emphasizing that the use of that. The other important information is your mathematical skills. So you see here, you must bring your tech math skills. Those who are doing pure math, you must bring your mathematics skills as well. So we're saying the use of mathematical formula that is provided in the data sheet. the issue of the scientific notation, the issue of conversion of units. You will see some of questions will give you in millimeters and centimeters, and you have to convert them to meters. So it's very much important you know how to convert from one SI unit to another. And then the issue of vectors, I've emphasized that. The issue of interpretation of the graph. Remember, in your graph, you'll have your independent variable, which is on your x-axis, and your dependent variable, which is on your y-axis. So it's very much important to know all the time that the independent variable will be on your x-axis. Remember, the independent variable is the one that you are changing during your investigation. You change your independent variable, but your dependent variable is the one that you are measuring. So you measure the dependent variable. So please don't forget to understand the graph. Is good to understand the variables, to say we have the dependent variable, we have the independent variable. We can keep one variable constant or two, then you must know as well which one is the controlled variable. So we're saying we have three variables when we're dealing with graphs. Is the dependent variable on your y-axis, the independent variable on your x-axis, as well as the control variable that you are remaining the same during the experiment or during the investigation. So those are very much important for our questions. Now, I felt that it would be important for the purpose of this revision program to ensure that we start with revision. However, let's use previous question papers so that you are able to see what happened. So I will be looking at the paper that you wrote in June. Some of the questions, if not all, will come from there. There is a June paper that was written for supplementary. So it's our supplementary paper for the learners who wrote last year and who were writing this year. So we'll be looking at some of the questions from there. But our focus will be on waves, sound and light, electricity and magnetism. So that 57 marks is our focus, and we are hoping that this will help you to get those marks. Now let's look at the phenomenon of dispersion. So we are saying the dispersion of light is there. Remember, we said when you're given multiple choice questions, you're given 4 options, which means you have 1/4 chances of getting the answer correct. And if you convert that to percentage, it means that at the beginning you have 25% chances of getting the question correct. So you've got to know that you have 25% chances. How do you increase your chances of getting the question correct? And then for you to do that, we're saying remove the distractors. Those questions, those answers that are given as options but which are wrong. So you have to first take 2 disruptors because you want to increase your chances to be 2/4, which will be 50%. Then you have the likelihood of getting the question correct. I hope that helps you. Now look at option number 8. It says dispersion is the bending of light. The bending of light as it passes between media of different optical densities. So you will be able to know that, oh, the bending of light, okay? Then you will think about reflection and refraction. But this one is passing, so you will look at refraction in that direction. Now we are saying option number B cannot be A cannot be dispersion. Option number B is saying the change in direction of light ray as it hits a barrier. So we are saying it hits the barrier, it changes the direction. That cannot be dispersion. So you are able to see that option number A and B are wrong. Let's look where our chances is that C or D might be the correct answer. Spreading out of light as it passes through the edges of a small hole. That cannot be. Then breaking of white light into its component colors. So you know that when the white light breaks into its component colors, then we are having a concept referred to as dispersion. So you are able to get your 2 marks. I hope you got that and is able to help you as you prepare for your revision. Now let's look at 1.8. It's saying which one of the following units is used to measure frequency. Remember, you must know that frequency is 1/period. 1/period, and then the SI unit cannot be seconds. 1/T cannot be seconds. And then you know as well that joules, we use them to measure our energy and our work. When we're doing work questions and energy questions, you measure them in joules, not frequency. So you can see that between B and C, the correct answer will be hertz. Frequency is measured in hertz. So you're able to choose the correct answer and get your 2 marks. And that question is important that you know frequency that is measured in hertz. Now, let's look at the issue of capacitance. And when we're dealing with electrostatics, we talk about the capacitance of a capacitor. So we've got to differentiate between these two, that a capacitance is a measure, and then a capacitor is a device. So that's the first thing that we'll look at, between the difference of between the capacitor and the capacitance. So when you talk to the issue of capacitance, you're talking about a measure, and when you talk about capacitor, you're talking about a device. You will see when you do the sections so that you remember as well the definitions as well. So they're saying the capacitance in a capacitor will increase when. So this is very much important. I find it very much important that you have to know the data sheet. You must have the data sheet at your disposal to be able to see the formulas that are given on the data sheet when it comes to capacitance, because if you remember that, it will help you as well when you answer questions like this one. So if you look at this question, which was question number 1.9, it was saying the capacitance will increase when the dielectric with high dielectric constant is used. That looks correct. A dielectric with a lower dielectric constant is used. That is wrong. The distance between the plates increases. Remember, as the distance between the two parallel plates increases, then we are saying that the capacitance will decrease. So you know that distance is inversely proportional to capacitance. So that cannot be. The distance between the plates decreases. So when the distance decreases, the capacitance will increase. Remember, we're taking that from the formula. Capacitance is the epsilon 0 A over D. So you see the relationship between the capacitance and distance is inversely proportional. To say, as the distance increases, capacitance will decrease. As the distance decreases, capacitance will increase. In this case, we're referring to an increase. So the correct options was given as number D or A. So you had two options that were given there as correct answers. Then you are able to choose that as you move forward. Now, let's look at question 1.10, still from your May-June exam that was returned this year. They're saying a device that converts electric energy into mechanical energy. It's very much important to know that when you're dealing with this question, it belongs to motors and generators. So you're talking here of motors and generators. And you must be able to know by definition that a generator converts from mechanical energy to electrical energy. You must write it in full. And a motor converts electrical energy to mechanical energy. And the question is about electrical energy to mechanical energy. So you're able to see that your answer there by definition is a definition of motor, and it's not a definition of a generator, it's not a definition of a capacitor, and it's not a definition of a transformer. So it's a definition of a motor, that a motor converts electrical energy into mechanical energy. So you're able to choose a motor there, and you are able to get your 2 marks. And I hope that will help you as you prepare. So we're saying simple definitions, you can get them as well in your multiple choice questions. So it's very much important that you practice as many questions on multiple choice as possible. Remember, multiple choice, we're having 20 marks there. So 20 marks is about more than 13% of the paper. So we're emphasizing that please practice multiple choice. It's a skill to be able to know how to answer multiple choice questions. Now we're going to deal with question 6, which is based on the topic wave, sound, and light. So we're focusing on light. As you know that in grade 12, our focus is light. Now, here we're having a light ray which strikes a reflective plane surface at an angle of 58 degrees with the surface. So we are given that. So you are able to look there to say, is this reflection? is this refraction, is this dispersion? Because you got to be able to differentiate between those concepts to say, when do we say is refraction? When do we say is reflection? So you will see as you deal with the questions, they will be based on that. The first question is define the term reflection. So it gives you an idea that here we're dealing with reflection, because if something is reflected, it means it is sent to the source, and then that source is able to set the image back where it's coming from, or the light. The light is able to come back. So the definition must be able to respond to that, to say what is reflection. And by merely looking at the diagram itself, without, let's say you have forgotten what is the definition of reflection, you can see that there is change in direction of light or a wave, a change in direction of a wave upon striking the interface between two materials. So you are saying we are having two different materials. The material that the object is the light is bombarding here or hitting, and then we are saying when there is that change in direction, when the wave hits or strikes the interface between two materials, we refer to that as reflection. Or in simple language, you can say is the bouncing back of a wave when it strikes an interface between two medium. So we're saying we have medium A and medium B, or I can say medium P and medium Q, not to confuse you with the A and B, which is our light rays there. So you are able to see that the definition now, if you looked at that, you are able to say this is the change in direction of a wave upon striking the interface between two materials. So you are saying these are two materials, material P and material Q, and you are saying the change in direction of light or of a wave upon striking the interface between the two materials, we refer to it as reflections. Then you are able to get your 2 marks. Or you can just say is the bouncing back of a wave. I don't know why I love the bouncing back of a wave, but you will choose the one that is more suitable for you, and then the one that you remember better. So I think the bouncing back of a wave when it strikes an interface between two media. So if you write any of those two definitions, you will get that marks. And one thing that I must emphasize is that in this section of light, there are many definitions that we have, as I indicated: reflection, refraction, dispersion. So it's important that you know all these definitions, because you can be able to collect many marks through these definitions. Now, as the question 6 continues, you will be able to see that now we are still dealing with the same light ray that is striking the interface and is now being reflected. Now the question says label the following. So all you have to do is to label. So we are given OB. You can see OB. So you have to look at it to restart a reflection or what is that OB. What do you do? Label it as. So you'll say this is a reflected ray. You will refer to it as a reflected ray, and you are able to know to get your mark. Now, angle 1, you are calling it the angle of incidence. So if it means the ray, you will call it incident ray, or the ray of incidence. So you have incident ray, you have a reflected ray. So you have two rays, is the incident ray and the reflected ray. And when you have the incident ray, you are having the angle of incidence. And when we have the reflected ray, we'll have the angle of reflection. So it's very much important, because I'm answering for you now 6.1.4, and I've seen this question being repeated in many of these papers. So it's very much important that as you revise your work, as you do what you are supposed to do, be able to know that you have the angle of, where you have the incident ray, you must have the angle of incidence. Where you have the reflected ray, you'll have the angle of reflection. Please, those are free marks that you must just collect, and make sure that you understand this concept and you are able to write and pass your exams with flying colors. Now, we had a question that says, what is the relationship between angle 1 and angle 2? So we are saying the angle 1 is equal to angle 2. So the angle of incidence is equal to the angle of reflection. So don't forget that the angle of incidence is equal to the angle of incidence is equal to the angle of reflection. So the two angles are equal. So at all times, always remember that the angle of incidence is equal to the angle of reflection. Remember, this was a paper that learners wrote. You had 2 marks there, you had 3 marks there that you collect. So we're saying, take it easy, get your time, sit down and practice these questions, and you will be able to collect these marks. So this is question 6 of the May-June paper. As it continues in question 6.2, it says the diagram below shows the path of a ray of red light. Now, they are saying the light that we're talking about is red light. Remember, under those visible light, we have your red beam, which is your red, orange, yellow, green, blue, indigo, and violet. In this case, they gave you the red light. So you are able to see that, okay, now we have the red light. Now, when this light, study the diagram carefully and answer the questions that follow. So you can see that we have the light that is incident there, and then it goes back, it's reflected back at the end of the day. So what is this phenomenon referred to as, or what is the name the phenomenon observed in the diagram? So you can see that all the light is being reflected back. Then we refer to it as total internal reflection, because it's total internal reflection. So everything is being reflected inside like that. Then that is the concept. We refer to it as total internal reflection. Remember, initially we talked about the reflection, where the light was now changing in direction. In this one, it happens inside, and then what is happening is that this one, we refer to it as total internal reflection. You can see with that, the first concept, we had light that was hitting the interface and light was being reflected at the interface. But here you can see the light is penetrating, but it's being reflected internally. Hence, we're referring to it as total internal reflection. I hope you get that, and it helps you as you prepare to understand the concept of total internal reflection. Now, state 2 applications of the phenomenon in question 6.2.1. We said it is total internal reflection. So it's total internal reflection. So the question is saying, state 2 applications. Where do we use this concept of total internal reflection? Where do we use this concept of total internal reflection? I hope you are thinking, you are writing down where we use it, so that you are able to answer, to mark your own question. So you can write down where do we apply this concept of total internal reflection. We have so many options as answers that are given for this option. Number 1, we are using it in the optic fiber in telecommunication. We are using it in the automotive rain sensors, optical fingerprinting devices, sparkling brilliance of diamonds, binoculars. I hope you know the binoculars, the periscope, and the endoscope. So all that, remember the question said you must write 2. So you will now be credited 2 marks for writing 2. You don't have to write all of them because the question said state 2. However, when you write them in your memorandum, we'll try to put as many options as possible so that we are able to answer, to mark you correct. As long as you mentioned the application which is correct, we'll definitely mark it correct. So we are no, I'm saying not that we have all the options. If there are other options that you know where we use the concept of total internal reflection, you will be awarded 2 marks as long as you wrote the 2 that are correct. Now, the question when it goes 6.2.3, it says write down 2 conditions for the phenomenon in question 6.2.1. So we are saying there are 2 conditions for this total internal reflection, and the question is saying write down these 2 conditions for total internal reflection. Now, the first one is that the light must be traveling from a more dense medium, so a denser medium, into a less dense medium. So it must come from a less dense, from a denser to a less dense. So that's the concept it will work. For example, from glass, which is more dense, to air. And the angle of incidence must be greater than the critical angle. Remember, when we're dealing with the issue of reflection, we said the incident angle is equal to the angle of reflection. However, when it comes to a total internal reflection, we're saying the incidence angle or the angle of incidence must be greater than the critical angle. So you got to get that and know that that's how we apply this concept. Now, 6.3 is now going to deal with the issue of lenses. So you know we deal with the issue of convex lens as well as concave lens. So we're going to look at this question, and then you might be asking yourself to say what type of a lens is this, because definitely that will be one of our questions. Now we're saying the ray diagram below shows an image of an object placed between F and 2F. So you can see that the object is placed between F and 2F. So we had our object here. So you got to see that first to say, okay, we're having the object between F and 2F of a lens. Now, the first question we're asking you is what type of a lens is this one? Is it convex or concave? Hope you responded correctly to say this is a convex lens. So we're going to use a convex lens, and then we're saying state two properties of image formed by the lens in question 6.3.1. So you can see if you look at this image, the object is between F and 2F. But if you look at the image, is further away from F, and you have passed to F as well. It's not in the same position as it was as an object, our original object. So you can see that it's here after 2F, but the object here was between F and 2F. And the other thing, you can see that our object was upright, it was looking up there, but here now we can see that it's inverted. So as you answer the questions, just look at the object and look at the image to say what is different about that, and you can be able to explain the question which says two properties, or to name two properties of the image. So we're saying the image is real, is inverted, is enlarged. So if you look at the size of this image, it's not equal to this one. So it is now enlarged. It's now enlarged and is beyond 2F, as I said. That is beyond 2F on the opposite side of the lens. So you can see that any two of those answers will do. So these type of questions, remember we're saying state two, but you have many properties. It increases your chances of getting the question correct. So practice these lenses. On this question in May, June, we had a convex lens. You might get a concave lens in the other exam. So practice both of them, the concave and the convex, and be able to understand the properties of the image that are formed, so that you are able to answer the questions with no difficulties. Now let's look at 6.3.3. It's saying give two uses of the lens in question 6.3.1. Where do we use this lens, which is the convex lens, which is real, is inverted, it's enlarged? So ask yourself the question, are human beings, the eyes, are we using concave or convex? Those are some of the questions as you are doing your thinking process. You will think where we use this. Just things like cameras, what type of lenses are they using? So you ask all those questions and be able to respond to the question. We only needed two options, but you can give as many as you can. So you can see here, you can use the magnifying glasses, you can use it in the optical microscope, the projectors. I think you have seen the projector at your school. Educators might be using projectors for teaching and learning. Your cameras, and then you have cameras even in your phones and all that, your human eye, your telescope, all these are using the convex lens. So it's very much important that you know where do we use these convex lenses, because when we ask you such questions, we're saying two, but we gave options there. But if you have other options as well, that will add on the options that you are having. Still, you are able to add that, and we won't have a problem. Now, the last question is give a reason. I mean, question 6.3.4 is saying give a reason why no image is formed when the object is placed at F. Remember, our object is between F and 2F. Now, the question is, if now we take the object, this object of ours, we take it, we put it here at F. The question is saying, if we put it at F here, why there will be no image that will be formed? So that requires your critical thinking as well as you respond to that question to say, okay, between F and 2F, we are able to get the image. But now the question is saying, if we put it at point F, it's saying there will be no image. And you have to give the reason why, as we go towards point F, there will be no image. And the reason given is that the refracted rays, or the rays passing through the optical center, they are parallel, do not meet, and therefore the image will not be formed. Remember, for this image to be formed here, you have the refracted rays that are meeting there. But now it's saying if you put it at point F, these refracted rays will be parallel to one another. And if they are parallel, it means they won't touch one another. And if they don't meet, then image won't be formed. It means one aspect that is important is that for the image to be formed, these refracted rays must meet at a point. Then image will be formed. So we're saying because they are parallel, they do not, or because they do not meet, then the image will not be formed if the object is at point F. So as you practice, look at all that, and you are able to remember and understand this concept of lenses. As I've emphasized, I'm still doing that now to say, remember, we do both convex and concave. So learn all of them so that you are able to remember and be able to get your marks. Now, with no wasting of time, we'll be moving to question 7. So now we are done with the light, the first part of light, which was focusing on your lenses and your reflection, your refraction, your dispersion. But now we're going to look at the electromagnetic radiation. We're still talking about light of different, we're still talking about light here, so it's still the same. Remember, you are having these types of radiation. So you got to know this. I hope you know this type of light, which I usually refer to it as Raman-Fuchs, so that you remember them. So I usually say Raman-Fuchs, so that you are able to know that we have the radio wave, the microwave, infrared, visible light, ultraviolet ray, your X-ray, and your gamma ray. And I'm very much interested on the visible light, because remember, that's where you're getting your lights. Your ROIC beef is visible light. So your visible light, your red light, you know them, the orange, the yellow, the green, the blue, the indigo, the violet. Others will refer to it as VIBGYO. It's still the same, but still referring to the same light, which are now referred to as ROIC beef. So you can see that even this visible light is part of electromagnetic radiation. So electromagnetic radiation, I was saying you have your radio wave, your microwave, your infrared, your visible light, your ultraviolet violet ray, you are having your X-ray and your gamma ray. The other important thing is to know where do we use the radio waves. You can see from the name itself, radio waves. I think you'll be thinking about the normal radio that you use, the microwaves as well. Where do we use the microwaves? The infrared. We talked about the visible light, which is the light that we have. The UV light. I think you know the UV light because you're exposed to it. when there is a sun and all that. You have heard people talking about X-ray and then our gamma ray as well. So this is a topic of choice that if you look at it, it's talking to even to our lives as well, our day-to-day lives. And it's important that you understand. And we are saying these waves, they all have their wavelength, and they have wavelength, they have frequency, and energy. So those three things you can't talk, they are very much related. I would like to remind you that when we're talking about light, the speed of light we said is c, which is 3 times 10 to the power of 8 meters per second. So that is 300 million meters per second. That is the speed of light. Light travels with that speed. And we have the formula c equals to f lambda. So c equals to f lambda is our formula. So you are able, when you are given wavelength, you are able to calculate frequency. And if you are to make wavelength subject of the formula, you say wavelength is equal to c over lambda. And then you can say as well, make f subject of the formula, which is c over c over f. Sorry for that. So I'm saying wavelength is c over f, and f is c over lambda. So you can see what we're trying to emphasize here is the relationship between the frequency and wavelength. We're saying the frequency and wavelength are inversely proportional, meaning that if you have highest wavelength, you will have lowest frequency. So that is the first relationship that we must look at to say, okay, the relationship between frequency and wavelength when the speed of light remains constant, which is 3 times 10 to the power of 8 meters per second. So we're saying frequency and wavelength are inversely proportional, meaning that if you look at this wavelength that were given here, you will see that we have 10 to the power of 10 to 10 to the power of 4. That is for your radio waves. So you can see that this is high, very high wavelength, which means lower frequency. So high wavelength means lower frequency. So that is the relationship because they are inversely proportional. In this question, we are given the wavelength. In the other question, we can give you the frequency as well. So we know the relationship that the radiation that is the highest wavelength has the lowest frequency. The same applies with gamma rays. It has the lowest wavelength, which means it has the highest frequency. So that is the first relationship that we must look at to understand this topic of electromagnetic radiation, is to look at the relationship between the frequency and wavelength, the inversely proportionality there, to say as the wavelength increases, the frequency decreases. Now, immediately when you understand that relationship, you will go to energy of a photon, which is given as E equals to HF, because we are saying this light is, this energy of a photon is like a packet of energy, so which is given by HF, where your H there is your Planck's constant, which is given for you for free. So you just go to the data sheet, you find Planck's constant, which is your H there, you just write it there. So the only thing that you need is frequency. Now, in a question where you're given frequency, you will simply use this formula and substitute H, which is Planck's constant, and substitute F, which is the frequency. So it depends on the type of question that you are given. However, if you are given a question where you are given now wavelength, because we can give you wavelength and say calculate energy of a photon, you got to know that E equals to H, F, then the F we said is the same as C over lambda. So where there is F, you can write C over lambda, then your formula can simply become E equals to H C over lambda, because we said C over lambda is the same as frequency. So you are able now to know that energy of a photon, you can use this formula E equals to HF. If you are given a wavelength, you can now say E equals to HC over lambda. Still, you will get the same answer. So I'm hoping that will help you going forward in order for you to be able to answer this type of questions that you can be given. Now, if we look in our question 7 for the paper that was written in this May, June, we are saying a photon, which is, I said, it's a packet of energy and is given by the formula E equals to HF of an electromagnetic radiation. So you know electromagnetic radiation, we said is all those Raman-Fuchs, which is your radio wave, microwave, infrared, visible light, ultraviolet ray, X-ray, and gamma ray. Now, they are saying has a frequency. So frequency is given in this case. So if we were to ask you to calculate the energy of a photon, when the frequency is given, it's easy because you'll write the formula and you'll substitute, because we are emphasizing that H is Planck's constant and is given in the data sheet. You just have to go and copy it from there. So in this case, you are given 2,4 gigahertz. So the main issue is, will you be able to convert gigahertz to hertz? Because if you forget that, it's going to affect your answer. So the interconvention between units is very much important, because we're saying frequency. There was a question in the multiple choice that asked you to say, what is the SI unit that we use for frequency? And you were able to say frequency is measured in hertz. You said frequency is measured in hertz. You can just write HZ. It's measured in hertz. So it's very much important for you not to forget that frequency is measured in hertz. Simply means that now we are going to, we're not given hertz, we're given gigahertz. So you got to remember how to convert from hertz to gigahertz. So that conversion is important because your answer will depend upon that. But now, without wasting time, I hope the background that I've given you will help you to be able to respond to a question like this one. Let's look at this question, for example. They're saying for this photon, calculate the energy. So this is energy of a photon. And already we talked about the formula to say the formula for the energy of a photon is E equals to HF. And H is Planck's constant, which is given your 6,63 times 10 to the power of minus 34. And you were given your 2,4 times 10 to the power of 9. You see now, giga means to the power of 9. So if you don't know how to convert to gigahertz, you see now you are going to get a mark for the formula. Now we're going to go to lose a mark just for conventions, because remember this is a 3-mark question. So you got to know how to convert. So please guys, spend some time looking at how do we convert from centimeters, millimeters, mega, whatever that you have to convert to, so that you know how, because we'll give you questions in wavelength, in nanometers, in picometers, centimeters, and you know that the unit must be meters for your wavelength, and the unit for your frequency must be in hertz. So if we give you gigahertz, you got to first convert, which is what we have done here by saying times 10 to the power of 9, which stands for that giga. Giga is times 10 to the power of 9. I hope that helps you, and it will help you as you practice. You simply have to take your calculator and multiply 6,63 times 10 to the power of minus 34. You multiply it with 2,4 times 10 to the power of 9, and it will give you the answer 1,59 times 10 to the power of minus 24. Now, in the next question, it says calculate, remember 7.1, it's saying calculate the wavelength. So 7.1.2 is saying calculate the wavelength. And we talked about this to say E equals to HC over lambda. That can help you as well if you are going to look for that. But if you know your frequency as well, you know that we said C equals to F lambda. So we can simply make a wavelength subject of the formula, which will be C over lambda. C over frequencies, that will be your wavelength. So you are able to do that. But it's important to go to the data sheet and copy the formulas given in the data sheet. We don't want you to be changing and making the subject of the formula, because that's where you are prone to making mistakes. If the formula in the data sheet is given as C equals to F lambda, just copy it as is, and then you are able to know that, okay, do we know C? Yes, it's a constant. We said it's 300 million meters per second, or 3 times 10 to the power of 8 meters per second. Do we know the frequency? We said it's 2,4 times 10 to the power of 9. Then you are able to calculate your wavelength. And as well, you can come and use this formula because you calculated your E. I don't condone you using the formula that uses your previous answer, if there is a formula that doesn't use your previous answer. Because if you look at 7.1.2, if you are utilizing the formula wavelength equals to C over frequency. Frequency was given, C is constant, then you're looking for wavelength. Then you are sure that you can get your answer with no issues. But if you are using E equals to HC over lambda, if your E calculation here was wrong, it might affect your answer. However, we do use what we refer to as positive marking to say if you substitute the E that you got there, and forgive here, my E doesn't have joules. Remember, energy is in joules. SI unit must always be there for you to get the final mark. Thank you for that. And then that is your question. Then you are able to do the calculation. I hope where you are busy trying to do it, and as I'm talking like this, you might be done with the answer and you are willing to see how did we calculate this one. As I indicated, there are two options that we can have. Is wavelength equals to C over lambda, C over F, and then you simply, this one is a constant, and then 2.4 gigahertz was given as our frequency, from the statement. So you are able to get that, and you collect your 3 marks and look at that, then you are 3 marks richer. So you can see that this section of light, this section where you are dealing with reflection, refraction, dispersion, and the lenses really, and this electromagnetic radiation, if you spend time on that, it will help you come the final exams, and you will be able to answer and get as many marks as you can. As you can see, for 7.1.2, you will get 3 marks. We said there is another option where you can use the E equals to HC over lambda. Here's the option that we gave you there. And then we are saying that is option number 2. And we are saying for this option number 2, the E is the value that we calculated. However, we are saying positive marking from question 7.1.1. So even if you didn't get the correct answer on 7.1.1, but you calculated your energy, that answer, as long as you substitute here, you'll still be able to get your marks, because you'll get 1 mark for the formula for the substitution. And then the final answer is that the wavelength is equal to 0.125. So we are able to calculate the wavelength. So I think we have seen how to calculate the energy of a photon. We said you'll use E equals to HF. If another question gives you energy and say calculate the frequency, you will simply come and do the substitution there. And then we have seen how to calculate the wavelength. We say E equals to HC over lambda. You just substitute everything and you work out for wavelength. And then we said you can even use C equals to F lambda, which is the simplest formula that you can use to calculate your wavelength. Then you'll write that and you're able to get that. So I hope that this helps you as you are practicing. Then take it easy. It's as easy as we do it. And if you do as many previous question papers as possible on the topic of electromagnetic radiation, I'm telling you, you will be laughing alone during the exam. So practice, practice, practice. And we are saying you have these questions from 2018 to 2023 in May, June. So you can see you have a lot of material. So ensure that you have all those question papers and you are practicing them. And we are emphasizing that as you do your revision, if you are revising electromagnetic radiation, revise electromagnetic radiation, do electromagnetic radiation in all the question papers from 2018 to 2023, and then definitely you will do very well as far as these topics are concerned. I hope that helps you. Now, as the question proceeds, it says a photon of electromagnetic radiation has a frequency of 2.4 gigahertz. It's just a statement. We're just keeping it here so that you are able to answer all the questions. Now, the question says, use the table above to identify the type of radiation to which this photon belongs. Remember, you calculated your wavelength. You said your wavelength is equal to 0.125. If my memory serves me well, said the wavelength is 0.125 meters. You can go to the previous slide. Yes, we said the wavelength is 1.25 meters. Now, you are going to check here, where do we find 0.125? And then if you check on the radio waves, it's from 10, and this is less than 10. So this becomes, is out, this one. But look at microwave, it's between 10 to the power of minus 3 to 0.3. And you can see that 0.125 is between this range. So that range tells you that here we are dealing with microwave, and then you are able to know that this is microwave. But however, if, for example, in the previous question you calculated your wavelength, you didn't get your wavelength correct, and say maybe you got the answer, your answer that you got was 3 times 10 to the power of minus 5, for example, and then you come and say this is infrared, we'll still credit you a mark because you were able to go and identify, using your own answer, to identify the type of radiation that it is. So it's very much important that you are consistent and you answer all the questions. So even as you make mistakes, however, if you have the skill of being able to look at your answer and tell us that this answer suggests that the type of radiation is this one, we're able to credit you a mark for that. So it's very much important that you don't leave blank spaces because you have challenges and all that. Answer all the questions so that you are able to collect these marks, and then you will enjoy and pass the subject. Now we're saying give one use of the radiation in question 7.2. Imagine that. So microwave, I think you know the microwave, or you have seen the microwave and how it is used, more especially when you have your food that is cold and you want to eat, you will definitely use the microwave oven, or for cooking as well. You can as well, the cell phones, they're using microwaves, and in telecommunication we're using the microwave. So it's very much important to know that these microwaves, they are very much important even in our life. Hence we're saying give one use. Hence I emphasized at the beginning of this lesson to say no for each of these waves, type of radiation, to say where do we use them in our day-to-day life. Then you are able to know that if questions comes, the question might come on an X-ray. You know, when you're dealing with the issue of bones and broken bones and all that, people go for X-rays and all that. They're going to check all that. So know each type of radiation to say where do we use it on our day-to-day life. I hope that will help you as you revise and prepare for the exams, so that you are able to collect as many marks as possible. That was 7.3, and that was the question on electromagnetic radiation. I hope you got that. Now we are moving to the topic electrostatics. Remember, under electrostatics here in Group 12, we are dealing with capacitors and capacitance and capacitors. The capacitor itself, which we said is a device that stores the charge, and then we have the capacitance, which is now we are measuring how that capacitor works. Now it's very much important that you always refer to the data sheet. Always when you're starting the topic, we'll refer to the data sheet because it's going to talk to the topic that we are talking about. When you are stuck, you have to answer a question, define capacitance. You can come back here and be able to see, oh, it's a charge per unit positive charge, voltage, potential difference or voltage. So you are able to answer the questions even if you have forgotten. The formula is able to help you as you interpret the questions. For example, when we're dealing with the multiple choice questions, we talked about the issue of the distance, to say the distance and the capacitance are inversely proportional, to say as you increase the distance between your plates, what will happen is that the capacitance will decrease. But as you decrease the distance, the capacitance will increase. So it's very much important to know that as the other one increases, the other one must decrease. So you are able to see the relationship between them using the formula. And since the formula says epsilon 0 AD, you are able to see that as we increase the area, then the capacitance will increase as well. So these formulas, as you interpret them, they will help you. We are hiding the answers, some of them in your data sheet. Now the question now here says a parallel plate capacitor has a capacitance of 6 times 10 to the power of minus 12 farad and a charge of 0.3 times 10 to the power of minus 6 on each one of the identical metal plates. The metal plates are 5 centimeters apart. The dielectric material for this capacitor is air, so we're using air. Now, as I said, the definition, what is a capacitor? Is a device that stores electrical charge. Remember the difference between a capacitor definition and a capacitance. So a capacitor is a device, but capacitance is the measure. how the charge is being stored. Now we're saying 8.2 state the relationship between the capacitance of the capacitor and the charge. So you know from C equals Q over V, you know that as we show it here, the capacitance and the charge are directly proportional. So this question, if you have forgotten, just go back to the data sheet at the back and you are able to say the capacitance is directly proportional to the charge on the plates. You can even write it in symbols like that, will still be able to give you your marks. Then questions like calculate the potential difference between the plates and calculate the area of metals between the plates. So those are calculations types of questions, and you are able to calculate the potential difference. You see, we are at least we are asking you to calculate the V. Then you have to, we're given the C and the Q from the statement. Remember, the capacitance was given as 6 times 10 to the power of minus 12. The charge was given as 0.3 times 10 to the power of that. You simply substitute, plug and play, and then you are able to collect your marks. Here, have your math skills learners. We are saying practice it first at home, because you might have a challenge when you have to write 6 times 10 to the power of minus 12 equals to 0.3 times 10 to the power of minus 6 over V. Now you know the math behind the tech maths. Apply your tech maths there to say you cross multiply, then you get your 6 times 10 to the power of minus 12 V equals to 0.3 times 10 to the power of minus 6, and then you divide both sides by 6 times 10 to the power of minus 12. Please do this first on your own, so that you are not going to waste time during exam. Learn the skill of using the calculator as well, so that as you do these problems, you are able to do them as fast as possible, because you have been practicing. But if you don't practice how to utilize the calculator, in order for you to be able to do the maths type, tech maths type of questions like this one, you will have a challenge. Hence, we're emphasizing that please, the use of a calculator, and we always encourage you that if you have a calculator, continue to utilize that particular calculator. You know, it doesn't help you to change to buy a new calculator the day you're going to write exams, because you won't know how to use it. So we're saying have a calculator that you are using to practice with, and all that. Take that calculator to the exam, so that you know how to use it, and you will be more confident in utilizing that calculator. Then you are able to get your 3 marks. And then if the question is talking about the area, still you know the formula that is area, the epsilon 0 A over D. Then you just do the substitution, then you calculate your A. Remember, area is in meter squared. So it's just your math skills here to say how do we make A the subject of the formula. So I think hence we are emphasizing practicing here to say, okay, you know the formula is C for 8.3.2 is C epsilon 0 A over D. Now you were given the C here, you were given the this epsilon 0 is given, and then you have your A, you have your distance. Remember, you're given the distance as 5 centimeters apart. So if you forget how to convert from centimeters to meters, we're going to have a challenge. So you must know that centimeters times 10 to the power of minus 2, hence we wrote as 5 times 10 to the power of minus 2 there. From there, what is left is the tech math skill to say you must cross multiply. Remember, when you have a number like that, there is a 1 there. So as you cross multiply, you will get your 8.85 times 10 to the power of minus 12 A equals to 6 times 10 to the power of minus 12 times 5 times 10 to the power of minus 12 minus 2. Then you're able to do that. Then you must divide, because you want to remain with A only on the left hand side. You must divide both sides by 8.85 times 10 to the power of minus 12, both sides. So you're able to divide by that both sides. And then you let this calculator do the talking now. Then you are able to find your A as 3.39 times 10 to the power of minus 2. And your area is in meter squared. So we are mostly emphasizing there to say, please spend some time here and ensure that you know how to use a calculator. So because the only enemy you will have here is you being unable to utilize the calculator, being unable to convert from one unit to another. So the interconventions between the units is of paramount importance. As I've indicated, how to convert the centimeters. You have seen when we're dealing with the question on the electromagnetic radiation, we're given frequency in gigahertz. We're able to say times 10 to the power of 9. But those small things that if you are unable to do them, then they're going to affect the type of answer that you come with. So I'm emphasizing that, remember in grade 10, as you started with the subject, we showed you how to convert from one SI unit to another. Revisit those small pages and look at them and see how do we convert from this one to another one, from centimeters to meters, from millimeters to meters, nanometers, picometers. All those interconventions, they will help you. And as far as this question of capacitors and capacitance is concerned, if you have that, I'm telling you that you will do well in this question. You will enjoy it. We don't have many formulas in our data sheet. We are only having 3 of them: the C equals to Q over V, the C equals to epsilon 0 A over T, and the E equals to V over D. Only 3 formulas, and then depending on what we are asking you to calculate. So please ensure that you know how to utilize these formulas. As and when there are questions on this, you will be using them to answer questions. Now, we're going to our next topic, which is electricity. Now we're going to look at electricity, and it's very much important to know that in grade 11 you have done Ohm's law. So definitely you need Ohm's law as a weapon that you're going to use to answer questions in grade 12. So you can't say we've done Ohm's law in grade 11, then I don't have to know what Ohm's law, because those topics in grade 11, they are examinable in grade 12. So we're still going to say state Ohm's law here in grade 12, though you've done it in grade 11. So I'm emphasizing it so that you remember the importance of that. This data sheet is the most important tool in your hands that you can use depending on the question that you are given. Now, if you can check, we have the Ohm's law there. We have R equals to V over R. Remember, we are saying that now the relationship between the current and potential difference. We are saying the potential difference is directly proportional to the current, provided that the temperature remains constant. So don't forget that. We are saying these two, V and I, are directly proportional, which means as the current increases, as the voltage increases, more current will increase as well, provided that the temperature of the resistor remains constant. So don't forget, as long as the temperature is remaining constant at 25 degrees Celsius, we know that we don't have problems. Then Ohm's law will apply. However, if the temperature does not increase, for example, now you will see that our resistors, they are no longer obeying Ohm's law. They obey Ohm's law provided that the temperature remains constant. Now, we are saying as well, you will have resistors given in series. So when you are given resistors in series, your responsibility is simple, is simply to add them. You add them when they are in series, hence the formula is Rs equals to R1 plus R2 plus up to infinity. We don't give you many. We won't give you, for example, more than 4 resistors, maybe 5 resistors that are in series, or 6 or 7. No, we limit the number of the resistors that you give to yourself. So go and practice and know how to calculate the total resistance of resistors in series using that formula. Now, if you have resistors that are given in parallel as well, you must know how to calculate the total resistance or effective resistance of resistors that are in parallel. So please practice where you will utilize 1 over R parallel is equals to 1 over R1 plus 1 over R2. And I've seen that majority of learners, they find it easy to say after this, because we emphasize that always start by writing the correct formula from the data sheet so that you are able to get 1 mark. Remember, the 1 mark for writing the correct formula depends now on you substituting in that formula. So you must be able to utilize that formula, because we gave you this formula in the data sheet. So you can't just have a responsibility to copy it in your book and expect to be credited a mark. For us to credit you a mark, you must use that formula that we've written. So you can't just copy the formula and leave it and say, I will get 1 mark. No, you must be seen to be utilizing the formula to answer the questions. So hence, if you have 2 resistors in parallel, you will use that. If there are 3, you will add the 3rd one. If there are 4, you will add the 4th one. And we find it easy for learners after the step to say R parallel is equals to 1 over R1 plus 1 over R2, and just take the inverse of that. It makes it much easier. You are able to get your R parallel by simply substituting and pressing all that in your calculator. It will definitely give you, the correct answer. So we like you to do that. But the main thing that we're emphasizing, first write the correct answer from the data sheet. So we're saying when you have resistors in series, you will use that formula. When you have resistors in parallel, you will use that formula. When you have the combination, you will resolve the parallel combination first, then you add them because they will all now be in series. So hence I said this data sheet is the most important data sheet. From definition, we say that current is the rate of flow of charge, So the rate of flow of charge like that is your current. That is the formula that is given, Q equals I delta T. So know that if you are given your time, if you are given your charge, you can calculate current. If you are given your current and your time, you can calculate the charge. Whichever the case, you are be able to utilize that formula. And we have the formula that we use for energy dissipated, the work done, which is your W equals to VQ, W equals to VI delta T, W equals to I squared RT, and W equals to V squared delta T over R. So you can see that we have many formulas. Power, you will get many questions that want you to calculate power. P equals to, power is the rate at which work is done. Define power. You said power is the rate at which work is done, or the rate at which energy is dissipated. So still define your power and know that that's how you calculate power. And then P equals to VI, P equals to I squared R, P equals to V squared over R. So all those formulas depending on given information. So it's very much important here, learners, I must emphasize, to say ensure that you do your data collection, because your data will tell you which formula is appropriate to answer the question that you are asked. So I hope that helps us. As we move forward, you are able to see that. We are going now to deal with questions, because today we want to exercise and look at questions, strategies to say, how do I answer this type of questions? Now let's look, still looking at the May June paper, to say, let's go through it and look. That is our paper. We've tried to fit it in one page so that you can see everything, and then we're able to look at the questions. Now, this preamble, the statement there says, and one thing which is important that we sometimes I don't emphasize, I would like to emphasize now, is that you see the question says question 9, start on a new page. I mean, we're not going to say that if it was not important. It's important that you start a new question on a new page so that we're able to see your work is neat and everything, even in terms of our marking and all that. You start every question on a new page. It helps, it makes it easier even during marking. Then when you're marking your work, it's neat. Even yourself, you'll be able to check question 1, question 2, question 3. You can see we started with question 1. We're doing multiple choice questions. We're at question 6, 7, 8. Now we're in question 9. Now we're saying the circuit diagram given below was used to investigate the relationship between the current passing through the resistor R and the potential difference across it at constant temperature. So for a tech science learner who has been doing this subject, who knows Ohm's law, Ohm's law will come to head to say, okay, we have the potential difference, we have the current, and they are saying that temperature remains constant. So you will know that Ohm's law applies here to say we have the relationship R equals to V over I, which means the potential difference is directly proportional to the current, provided that the temperature remains constant. So T is constant. Temperature must remain constant for Ohm's law to apply. Now, they are saying now the results are shown in the graphs of current versus potential difference. It's very much important, to know that we won't at all times just be giving you a circuit diagram. Sometimes we'll give you a graph like this one. So interpretation of graph, as I emphasized at the beginning of this lesson, to say, know that on the x-axis we have our independent variable, on the y-axis we have our dependent variable. Remember, dependent variable is the variable, the one that we are measuring during that investigation, and your independent is the one that we are changing as the experiment goes on. So it's very much important for you to know your variables, because it will help you as well as you answer the questions. I hope that helps you and makes you ready for this question. Now let's analyze the graph. We're given now, you can see two graphs, graph A and graph B. Interesting. And you are seeing that on the y-axis, which you said is our dependent variable, what we are measuring, the dependent variable is current. So we're measuring how much current is flowing as we increase, as the potential difference increases. Remember, we are changing the potential difference, which means we started with the potential difference of 0. There was no charge, or there was no current that was flowing. But as we increase the potential difference or the voltage, you can see that there starts to be now current is increasing. So you can see the relationship already between current and potential difference. You can see that as the potential difference increases, the current is decreasing. So you can even come to the issue of directly proportional. You say, okay, they're directly proportional. And from the statement, they said already that the temperature remains constant. So you know, as the temperature remains constant, and we have I and V that increase as the other one increase. So you can see that Ohm's law, definitely it applies to this type of situation. Now, as we look to this, it's saying, for this investigation, identify an independent variable. So for you, you will know that independent variable is the variable that we are changing and is on the x-axis. So please don't forget that. So you are able to see that potential difference is our independent variable. You can say potential difference. Others, they can say voltage. Will allow that answer of saying voltage, which is measured in volts. So you are able to know that that is our independent variable. It means it's the variable that we are changing during the investigation. And then what is our dependent? What we are measuring is on the y-axis is our current. So others will just say current, others will say I, which stand for the current. Then we're able to give you a mark. You see, now you're just collecting the marks just by being able to interpret the graph to say the x-axis is independent variable, the y-axis is the dependent variable. Now, the question is, look, write down the conclusion. Very interesting. Write down the conclusion that could be drawn from the shape of these graphs. So this is very much important. I think me and you have agreed that if you look at these two graphs, as the potential difference increases, the current as well. Let's look at A, for example. Let's look at 0.5, you can see the current is increasing. 1 at 1, you can see for both graphs, as the potential difference increases, you can see that even the current is increasing. For both graphs, you can see that the two of them. So we can conclude that the potential difference is directly proportional to the current, looking at the shape of this graph. So simply, or a simplest way to put this, you are concluding this by simply stating Ohm's law. This question is as good as we are asking you to state Ohm's law, because as we conclude, you will say the potential difference across this conductor is directly proportional to the current, provided that the temperature remains constant. So you are stating Ohm's law here to answer 9.2, and you are able to get your marks. So it's very much important that you stay with that and you are able to utilize that. Now, look at question 9.3. Use the information in graph A. So this is very much important to you learners to say, read the statement with understanding. They are saying, forget, for this question, forget about graph B, focus on graph A, because hence we're writing A there in capital, in bold letter and capital letter. You are able to see it is bolded there to say, please leave graph B alone. Focus on graph A. To do what? To calculate the power. So we're going to calculate the power dissipated by the resistor when the current is 0.6 amperes. So you got to look at it and say, okay, at least we are given current. So remember from the data sheet, if you remember the formulas that we had P equals to W over T. If I remember some of them, we had P equals to VI. We had P equals to I squared R T. All those formulas, they are there in the data sheet. You are able to go and look to say which formula is going to help us. But now, what information are we given? Because hence I'm saying the most important thing of all things, before you choose the formula, the most important thing is for you to write down given information, or we call it data collection. So data collection is at the center of you passing. Remember, for questions that needs calculations, all you have to do, go for data collection, because the data you collect, it will tell you which formula you are going to use. So if you choose if you collect your data properly, you won't have a problem with calculation type of questions. You will do very well in paper 1. Now, let's look at data collection. What are we saying? We're saying at 0.6 amperes. So you come to the graph, you look for 0.6 amperes. It's okay, 0.6 amperes. Which graph are we referring to? A. So we go 0.6 is here, and the graph is A. So you do like that. Then you are able to say, okay, I'm going to now know that for graph A at 0.6, what is the voltage there? Are you able to say, oh, we have the voltage of 1.5. But now, if you didn't interpret the graph correctly, you won't see that at 0.6 for the graph A, the voltage is 1.5. So please, you are able to get those two values. And if you now, you have V, you have I, which was 0.6 amperes given, you have V that you got from graph is 1.5 volts. So it becomes easier for you now to simply do the substitution to say, in these type of questions, I'm going to look for the formula that has a V and I. And if you remember well, the formula was P equals to VI, which now is simply there, you multiplying the V, which is 1.5, you multiply your 1.5 times 0.6. Then you just take your calculator and you multiply 1.5 and 0.6. And if you have done that correctly, you will get 1.5 times 0.6. It will give you 0.9. Remember, power is measured in watts. However, there are other methods that you can use. For example, you can first calculate the R using the voltage and the current, which is a long method, because with this you are still going to get 3 marks. But if you want to use P equals I squared R, you can go that road. You will still get the correct answer. Will still give you 3 marks, though you took a long road, but you will get the same answer. The same, you can use the P equals to V squared over R, which is now same V squared is your V, which is 1.5. Your R, you will have calculated it from here. So both option 2 and option 3, they need you to first calculate the R, which I think is a long method. But if you choose the method that is easiest for you, so follow the one that is easiest. But for me, I find the P equals to VI being a straightforward option, because you are given V, you are given I. You simply plug them and you use a calculator to multiply the two, and you are able to get your answer with no problem. I hope you understood that and you saw that this is a very nice question. And then as you practice, you are able to see that you can pass electricity. It's a nice question as well. Now, how does the resistance of graph A compare to the resistance of graph B? Oh, this is a nice question. Remember, they're asking you about resistance, but there is no resistance on the graph. We are having current and V, but the question is about resistance. So what you have to do, you know the relationship R equals to V over I. So you can see that E, where we have the highest current, we're having the highest current means lowest. So if the current is high, it means the resistance is low. So now let's look at graph. Let's look at graph between graph A and graph B. Now, if you can look graph B, for example, at 1,5, you can see the current is high, which means the resistance is lower. I want you to understand that. Let me stay there until you hear what I'm saying. I'm saying what you will do. Let's look for any other value that you can check. But the simplest one, the one we're working on, is at 1,5 volts. When V equals to 1,5 volts, let's look at the current for B. The current for B is there, which is around 0.3 amperes. For B, it's about 0.3 amperes. But for A is 0.6. So for A is double, is 0.6 amperes. So you can see that the one that is the highest current, it means it has the lowest resistance. Now the question says, how does the resistance of graph A? So the resistance of graph A is lower than the resistance of graph B. Why? Because graph A has higher current than graph B at that point. So you are able to show that as the current increases, the resistance decreases. So that is the issue of the relationship. To say if you have a higher current, you have lower resistance. If you have lower current, you have higher resistance. Now we are saying the resistance of A is lower than the resistance of B. I think you have understood and you have seen where it is coming from. You are able now to celebrate and say, okay, I got that one, it's on the back. Explain the answer in 9.4, which is what I was doing. So if you can look, you will be able to see that the answer there says lower than, and this is negative marking. So negative marking simply means you can't say higher than and write an explanation and still be able to get marks. No, if you said higher than, the goal you're getting is 0 there. So this is one of the ways that we use. So you got to know that you must say lower than. If you don't say lower than, you are wrong. Then the whole explanation, because you are explaining a wrong, you are supporting a wrong answer. So we don't mark that. So on this one is negative marking, meaning that if you must say lower than, nothing else but lower than. And when you do that, you are saying the gradient of graph B is lower than the gradient of graph A. Correct, you can take that. You can say the gradients of the graphs are the inverse of resistance, therefore graph B will have a higher resistance. Or you can say for the same current, the potential difference in graph B is higher than that of graph A. Potential difference is directly proportional to the resistance. Therefore, graph B will have a higher resistance. Or for the same current, the power output in graph B is higher than that in graph A. Power is directly proportional to the resistance. Therefore, graph B will have a higher resistance. So you can use all those explanations that you can use in terms of current, in terms of potential difference, or in terms of power. So you are able to support your statement and you are able to get your two marks. Now we are moving to our very last topic, which is now your motors and generators. And we are expecting on this topic to say as well here, you must collect as many marks as possible. So you have your data sheet, which you always talk to, and then you have your magnetic flux there. You have your Faraday's law, which is the induced EMF is the rate of change in magnetic flux. You have your formulas when you're dealing with transformers as well. You will be utilizing that. Now, with no wasting of time, question 10 as is given in this question paper that we're doing. But before I go straight to the question, there are few things that you cannot do this topic without understanding, and I would like to emphasize them. Remember, I will say when you're dealing with this topic, there is this. I usually will say, Marcos, this is the most important components of a motor or a generator. Either it's DC or AC. Remember, when you're doing motors and generators, we're saying you can do a DC motor or an AC motor. You can do a DC generator or an AC generator. Now, these Marcos that I'm talking about is, number one, you must have magnets. You can see we have the magnets which have both the north and the south pole. So we have the north pole and the south pole, and you must know that the magnetic field is always flowing from the north pole to the south pole. So the direction is from the north pole to the south pole. So that is the first thing, the mother, to say we need to have a magnet, and you need a coil or a conducting wire. In this case, we have a coil. You can see we have a coil now. The coil is between the two magnets. Now, it's either we're going to have a split ring or a slip ring. So understand that. A split ring, which we refer to as a commutator, is a ring. It's a ring, one ring that has been split into two. Hence, we refer to it as what? As a split ring. So you will see it will look like a ring. So it means we'll have something of that nature. Something of that nature, then you know it's the ring, it's a split ring. But when you talk to your slip rings, you are talking about like what were given there, something of that nature, then those are your slip rings. You see that it's not one ring that has been split, but it's flat. So if you have a commutator or a split ring, this is for a direct current. Either it's a motor or a generator. You will ask me later to say, how do we know whether it's a motor or a generator? So for DC, we're saying we'll have a split ring commutator, or we'll have a commutator or split ring. You can call it split ring or you can call it commutator. That is for DC. I always say to learners, you can look at this as a D, this part of the split ring as a D, then you are always going to remember that, oh, this one is for the DC, but you can see we don't have a D there, so you know those are slip rings. So slip rings are for AC, either a motor or a generator. Now the question is, how will I know the difference between a motor and a generator? And they were saying, for a motor is converting electrical to mechanical energy. So you see, it was part of the multiple choice question to say a motor converts electrical energy to mechanical energy, and for a generator it converts mechanical energy to electrical energy. Now the other thing that you can use to check whether this is a motor or a generator, I'm even referring to the one in front of you. You can check whether we have power, we have output or input. So remember, the output is the power being used or is the power being added to the system. So if we check here with a light bulb, which is an output, because you will see light there. So you can see that we're dealing with a generator. So a generator is generating electricity or electric current. So we are using the electromotive force there. We're inducing the EMF. EMF is being induced that makes our current to flow. So we'll have flow of current. So we have induced EMF in accordance to the Faraday's law. So in this one, because we have output, we are going to say this is a generator. And because we have slip rings, you see the difference now. Because of the slip rings, we're going to say this is an AC. And because of the output, which is a light bulb, we're going to say this is a generator. So this is an AC generator based on evidence. Slip rings tells us that this is alternating current. And then it's a generator because there is output, there is no input. If we had a power source, like a DC power source, like our SL there, that is supplying the system with the current, we're going to say this is a motor. So for a motor, we have a power source, which is the input, and for a generator, we have the output, which in this case can be a light bulb or anything that is using that electricity. Now, as I conclude the lesson, I hope now you can easily differentiate between a motor and a generator in terms of energy conversion and between the AC and DC. And you can see that our coil here, it is now horizontal. It is horizontal to the surface, which means we have maximum EMF. And because this is AC, if we were to draw the graph of the EMF, you were going to start it at maximum, because this coil is at maximum there. So your graph will start from there, and it's your AC, so it will go like that, alternating current, depending on the number of rotations that we're having. So it's very much important to know the implication of the coil, the way, and the magnetic field. If they are like that, they are horizontal like that, you know that we are starting with maximum EMF. But if it was vertical, we're going to start from 0. So you must know when your graph starts from 0, when your graph starts from maximum. I think I have explained that. I will, without wasting time, I will go straight to the questions. They says the diagram below represents a simplified diagram of an electronic device connected to a light bulb. How will each of the following changes below affect the brightness? So we're going to talk about the brightness of the bulb. Write down only, increase, decrease, or no effect. So you're just choosing out of those 3 options. If we use a weaker magnet, you must know that if you have a stronger magnet, you will increase the induced EMF, you will have more current flowing, the brightness will increase. But because we're using a weaker magnet, it will mean that the brightness will decrease. If the coil is rotated faster, so if you increase the speed of rotation of the coil, you will increase the induced EMF, meaning that you will increase the brightness of the bulbs. If you increase the number of turns in the coil, so what will happen? You will increase the brightness of the bulb. So I hope all this, as you revise these papers, I hope you have this paper already. You will revise it and go through it time and time again and do practice. And as this question comes, I hope you will be smiling, you will be enjoying yourselves, and we wish you all the best. Until we meet again, I would like to say thank you. I leave you with these words of Nelson Mandela that says, "It is in your hands to create a better world for all who live in it." Thank you very much.